Welcome students. In previous class we have discussed about heat energy and different type of thermometer. Today we will discuss on thermal expansion. So thermal expansion means the expansion due to raising temperature or increasing temperature. You can say we know and we have studied also that we have to make space between uh, two rail to prevent the accident or due to thermal expansion, and we know the hanging portion of the current wire in winter season these are becomes tight, and in summer season these are becomes loose. Okay, so at low temperature the interatomic space is small. With increasing temperature the vibration amplitude increases and interatomic distance becomes increased. Okay. For linear expansion there is three type of expansion. One is linear expansion, surface expansion and volume expansion. For linear expansion, with increasing length the length is increases, and increasing length is proportional to the initial length and proportional to increasing temperature. And from that we can get L2 minus L1 equals to alpha L1. Alpha is the called the coefficient of thermal expansion. We have studied also, and L equals to L naught into 1 plus alpha delta T. L naught is the temperature, L naught is the length at initial temperature, and L is the length at temperature which is delta T higher than initial temperature. This is called coefficient of linear expansion. It has unit and dimension. It has units degree centigrade inverse or Fahrenheit inverse or Kelvin inverse, and dimension is theta inverse. Okay. So areal expansion increase in area. There is also the coefficient of areal expansion beta, and we have also an volume expansion, and V2 equal to V1 into 1 plus gamma delta T. Gamma is called coefficient of volume expansion. Now we will do some problem. A rectangular block is heated from 0 degree C to 100 degree C. The percent of increase in length is 0.1%. What will the percentage of increase in volume? This is a simple mathematical problem. And they're given that del L by L equals to 0.1 by 100 as the length is increased, and we have to find del V by V. We know V equals to 4 by 3 means V proportional to L cube. For rectangular block V is L cube. Okay, then if I del V by V means 3 into del L by L. For small change we can use the differentiation. Okay, means 3 into 1.3% will be answer. Next, the relation between alpha, beta and gamma, the coefficient of linear expansion, volume expansion and surface expansion. The alpha equals to beta by 2 equals to gamma by 3. To understand, alpha by 1 equals to beta by 2 equals to gamma by 3. You can memorize by that way. Okay. So we can prove here also. To prove that alpha equals to beta by 2, we have to take a rectangular or square plate. Okay, let me do. Suppose I have taken a rectangular block or rectangular lamina having side L. Okay, at initial length L0. After with increasing temperature delta T, the length is increased to, and its area will be increased also. Its length will be changed to L0 plus delta L, and initial area surface S0 equals to L0 square. Now S equals to L square. Okay, where L equals to L0 plus delta L. Then you can see the S will be S0 into 1 plus beta delta T. Okay, or delta theta maybe, and also L equals to L0 into 1 plus alpha delta T. From these two equations, and also S equals to L square, just use this formula and you can get alpha equals to beta by 2. To prove alpha equals to gamma by 3, we have to choose a cube. Okay, which side, each side length L or L0, and then with increasing temperature its size will increase and volume also increase, and you can prove that alpha equals to gamma by 3. Now we will discuss some question. When a metal rod is heated, it expands because the distance among atoms increases. We have told. Here the question: two uniform brass rod A and B of length L and 12 and radii 2r and r respectively. Okay. So two brass rod, one have length L and radius 2r, another has length r and length 12 and radius r respectively, are heated to same temperature. The ratio of increase in its volume A of A to the B. So volume will be for the rod A, the volume V1 will be 4 pi r square L pi into 2 r square into 4 pi r square, and volume of rod B is V2 also 2 pi r square L. Pi r square into 12 means 2 pi r square L. The ratio of the increase in volume of A to B. As for same material, we know gamma will be same. Okay, that's why if the gamma will be del V by V delta T. Okay, so for the same temperature increase, del V by V we have to find. Means we need to del V proportional to V. Okay, so del V1 by del V2 equals to V1 by V2, or V1 will be 4 pi r square L and V2 will be 2 pi r square L. Then you can calculate equals to 4 by 2 means 2 by 1. Okay, this will be the answer. The volume of solid decreased by 0.6% when cooled through 50 degrees and the coefficient of linear expansion. So del V by V equals to gamma delta T we know, and also del V by V you have to find del V by V and delta T, and del V by V is 6.6%, 0.6 by 100, and delta T means 50 degrees centigrade. This is the gamma, and we know gamma will be 3 alpha. Then you can get alpha. Okay, alpha equals to gamma by 3. This question I have told is an important question. You can see that the coefficient of linear expansion of steel and brass are 11 into 10 to the minus 6 per degree C and 19 into 10 to the minus 6 per degree C respectively. Okay, and this is the alpha steel. This will be alpha S, and this is the alpha B. Okay, for brass, if their difference length of all temperature has same to be kept constant 30 centimeter, then their length at 0 degree C should be length for all temperature same means the changing length will be same with same temperature difference. So del LB will be LB alpha B delta theta or delta T, and del L steel, del S will be LS alpha LB naught, you can say LS naught alpha S delta theta, and del LB will be del S because the difference of length will be same, means how much length increased of steel will be same length increases of brass. So del LB will be del S, del LS, sorry, del LS. Then you can see that LB naught alpha B equals to LS naught alpha S, and LS naught by LB naught will be alpha B by alpha S. Okay, this is the solution. You have to put the data and you have to find the answer. A solid ball of metal has spherical cavity inside it. If the ball is heated, the volume of cavity will be increased. Okay, because with increasing temperature, the solid's volume increases and the hole inside the solid will be increased. Change in density. Density we know, density proportional to 1 by V. Rho equals to m by V, as m is constant, rho proportional to 1 by V. So if we increase V2 will be V1 equals to 1 plus gamma delta T, we know, but if I put density, then rho 1 will be rho 2 into 1 plus gamma delta. For solid and liquid we can Right, rho 2 equal to rho 1 into 1 minus gamma delta T. Okay, this will be the change in density. Now expansion of liquid. So in case of liquid, there the expansion is something different, because now we have to put the liquid into a container. Okay, so if we heat up, then container also will heat up, and the volume of liquid as well as volume of container will increase. Okay, so if we see the how much volume increased of liquid, we cannot get the actual increment or actual volume of liquid. We get or apparent volume, means the increment of volume of liquid with respect to the container. Again, as container is expanded, that's why we get slightly less expansion of liquid. Okay. Suppose container, suppose now I am getting the increment of volume is that amount. Okay. If container will not expand, then I will get the expansion will be like that volume. Okay, this will be the pink volume will be the actual expansion, and now I have got the volume is apparent expansion. This will be the this volume. Okay, this is the apparent expansion. So here is two type of coefficient of volume expansion. One is called apparent coefficient of volume apparent expansion, and coefficient of actual expansion. So actual expansion will be V minus V naught. This will be the actual expansion. V naught is the initial volume. Is the apparent expansion V dash minus V naught plus expansion of container. Okay, expansion of container. So if I divided by V naught delta T, then you can get the coefficient of actual expansion will be coefficient of apparent expansion plus coefficient of expansion of container. Okay, this is the relation. So here is a question. A cylindrical metal rod is shaped into ring. A small gap is shown. The heating the system. If we heat, then what will happen? Then X, R and D all will increase. The D increases due to surface expansion, R increases due to linear expansion, and X also increases due to linear expansion. As after expansion, the ring becomes also a ring, then the X will be increased. Okay. The term is thermal stress. Thermal stress means if I put a rod or metal rod between two wall and at particular temperature, and if you increase the temperature, this length of the rod tries to increase its length. That's why it's apply force on these walls. Okay, and this force per unit length is called thermal stress. Okay, so thermal stress is the stress due to the increment of the length of a rod on the wall. Okay, stress per unit. And we know strain is the increase in length per unit length, del L by L, and Y Young modulus will be stress by strain, and here Young modulus will be force per unit area by del L by L. Okay. And we know del L by L will be alpha delta theta. Delta theta is the or delta T is the increase in temperature. Okay. So then Y will be, we know F by A by del L by L, then del L by L will be alpha delta theta, then we can get F equals to Ya alpha delta T. Okay. Ya alpha delta T. This is the relation, or this is called thermal force, or F by A means thermal stress will be Y alpha delta T or delta theta you may say. Another is change in time period of simple pendulum. We know the simple time period of a simple pendulum is 2 pi root over L by. With changing temperature, the effective length of the pendulum will change. Okay, that's why the time period of a pendulum will be changed. Okay. So in earlier day, there was no battery, no motor. In that day, the clock hand rotates due to the oscillation of pendulum. So that's why due to the weather change or temperature change, the length of the pendulum changes, and then the clock become fast or slow. So how much time will change? You can see that in summer season the effective length of pendulum increases. That's why time period means to complete one oscillation time is increased. That's why the clock becomes slow down. In winter season the L decreases. That's why time period decreases, means time of complete oscillation decreases. So the clock become faster. Okay, and how much time will change? The relation is that t equals to 2 pi root over L or del t by t, rate of change of time period will be half into del L by L. Okay, and del t will be change in time in complete time period will be half alpha delta theta into t. T is the time period and delta theta is the change in temperature. Okay, so in a complete day, if time interval is t, means for a complete day we can choose t will be 24 hour, then change in time del t will be also half alpha delta theta into t. Okay, there will be maybe n number of oscillation in a day, then you can multiply n by delta t also. You can multiply n delta t and there will be also nt. Okay, n delta t means total time of a day or time interval t. Okay, and then nt will be total time of a day or total time of interval. Now the anomalous expansion of water. We have studied also the expansion of water from 0 degree to on cooling from 4 degree to 0 degree C is called anomalous expansion of water. Okay, it has some advantages we have studied also. Okay. Now bimetallic strip. Bimetallic strip means the strip which is two metal strip riveted parallelly is called bimetallic strip. Okay, if we heat up, then the expansion of edge coefficient of thermal expansion is different for different strip. That's why the expansion will be different. That's why the strip will bend. Okay, if here alpha 1, if alpha 2 greater than alpha 1, then the strip having coefficient alpha 2 length will increase faster than having coefficient of alpha 1. Okay, that's why it will bend towards alpha 1, and we can find the radius of curvature of bending beam. These are some questions you can try. That's all for today's class.